Good morning, my dear students. This is Rajaarjun, Assistant Professor of Chemistry, BVRIT Narsapur. So, in last class, we discussed about preparation properties and the uses of polythene, polyvinyl chloride, and bakelite. So, today we'll discuss about preparation properties and the uses of nylon 6,6 and terling. Right. So, we all know that this polythene is formed by the polymerization of ethene, and polyvinyl chloride, that is formed by the polymerization of vinyl chloride. Next, bakelite. Bakelite is nothing but it is phenol formaldehyde resin. So bakelite is formed by condensing phenol with formaldehyde. So the initial step of the reaction, it results in the formation of ortho-para derivatives, that is ortho-hydroxymethylphenol and para-hydroxymethylphenol, which reacts to form a linear polymer called novolac. So first formation of novolac takes place. So during molding, at this point, hexamethylene tetramine is added. So the addition of hexamethylene tetramine, it provides formaldehyde and converts this soluble novolac into a hard insoluble solid of cross-linked structure, that is nothing but bakelite. So novolac plus hexamethylene tetramine gives rise to bakelite. So this is about bakelite, right? Phenol formaldehyde resin is known as bakelite. So today we'll discuss about preparation properties and the uses of nylon 6,6 and terling, right? So, right, fourth compound, that is nylon 6,6. So nylon 6,6, it is nothing but condensation polymer. So condensation polymers are nothing but these are mainly formed by the polymerization of monomers with the elimination of atoms or groups, right? With the elimination of atoms or groups. So nylon 6,6, it is nothing but a condensation polymer. So this nylon 6,6 preparation, so it is prepared by condensing hexamethylene tetramine, right? Hexamethylene tetramine. Hexa means 6 carbons, methylene, it is formed hexamethylene diamine. Hexamethylene diamine, not tetramine. Hexamethylene diamine plus adipic acid. Adipic acid is nothing but dicarboxylic acid. Adipic acid, that is CH2 taken 4 COOH and COOH n moles, right? Hexamethylene diamine and adipic acid, that is hexamethylene diamine and adipic acid. Adipic acid is nothing but dicarboxylic acid, right? So hexamethylene diamine, that is NH2, right? So loss of water. So like I said, it is nothing but condensation polymer, right? So condensation polymers are mainly formed by the polymerization of monomers with the elimination of atoms or groups. So here loss of water molecule, right? Loss of water molecule takes place. That is, so next NH, what should I write here? NH, CH2 taken 6, next NH, C double bond O, CH2 taken 4 times N moles. So this is nothing but nylon 6 comma 6. Nylon 6 comma 6. So formed by condensing hexamethylene diamine with adipic acid. Adipic acid is nothing but dicarboxylic acid, and the loss of water, right? Loss of water takes place. So this is about nylon 6 comma 6 preparation. Next, coming to properties and uses. Properties and uses of nylon 6 comma 6. Generally, nylons are highly insoluble in common solvents, but soluble in phenol and formic acid, right? So, insoluble. Nylons are generally insoluble in common organic solvents. Common organic solvents, but highly soluble in phenol and formic acid. Phenol and formic, phenol and formic acid. Formic acid. Yeah. Phenol and formic acid. And this nylon 6 comma 6, it possesses high temperature stability and also high melting point. High melting point, this is mainly due to hydrogen bonding between hydrogen atom of amide and oxygen of C double bond group, right? So it possesses high temperature stability and high melting point. And this high melting point is mainly due to hydrogen bonding, right? So high temperature stability, and also possess high melting point. Next, this nylon 6 comma 6, it is good electrical insulator. Right? Electrical insulator. Next, it possesses high chemical resistance. And the major application of this nylon 6 comma 6, it is mainly used in textile industry, right? Mainly used in textile industry, right? So it is insoluble in common organic solvents, but highly soluble in phenol and formic acid. It possesses high temperature stability and high melting point, right? High temperature stability and high melting point. Possesses high chemical resistance. Electrical insulator, used as electrical insulator, used in textile industry, and it is also mainly used. It is also used in automobile and telecommunication industry. Industry, right? So this is about nylon 6 comma 6. So this nylon 6 comma 6, it is formed by condensing hexamethylene diamine with adipic acid, right? And loss of water molecule takes place here, right? Nylon 6 comma 6. Next, properties and uses. Insoluble in common organic solvents, highly soluble in phenol and formic acid. It possesses high temperature stability and also high melting point, and this melting point is mainly due to hydrogen bonding. Right? Used as electrical insulator, possesses high chemical resistance, used in textile industry, used in automobile and telecommunication industry. This is about nylon 6,6. Right. Next compound, fifth one I think, pteryline. So this pteryline is formed by condensing terephthalic acid, terephthalic acid with ethylene glycol. So in the first step, this terephthalic acid preparation, it is also dicarboxylic acid, COOH. This is terephthalic acid. It reacts with methanol. First, it reacts with methanol to form dimethyl terephthalate ester, right? That is dimethyl terephthalate, COOCH3, dimethyl terephthalate, that is nothing but ester. One sec, COOCH3, that is dimethyl terephthalate. Right? First, terephthalic acid, it reacts with methanol to form dimethyl terephthalate. And this formed dimethyl terephthalate, it reacts with the next step is formed dimethyl terephthalate, COOCH2. It reacts with ethylene glycol, that is CH2OH and OH. Right? Ethylene glycol, right? N moles, right? So it reacts with ethylene glycol, dimethyl terephthalate. It reacts with ethylene glycol, right? And the loss of water, minus NH2O, right? And this pteryline is also the pteryline is loss of water, right? Here, loss of water molecule takes place, condensation polymer, right? Loss of water and forms pteryline, that is OCO and so on, right? OCO C6H5, CO CH2 and so on, CH2 O and so on. Yes. This is nothing but pteryline, right? Formed by condensing terephthalic acid with ethylene glycol. It consists of two steps. In step 1, terephthalic acid, it reacts with methanol and forms dimethyl terephthalate. In the second step, this formed dimethyl terephthalate, it reacts with ethylene glycol, that is CH2OH, right? Ethylene glycol and forms pteryline, right? So this pteryline is also condensation polymer, right? It is also condensation polymer. So condensation polymer, like I said, these are formed by the polymerization of monomers with the elimination of atoms or groups. So here loss of water molecule takes place, right? So this is about pteryline. Next, preparation and properties and uses. Coming to properties and uses. And this pteryline is resistant to friction. It is highly resistant to friction because of its high tensile strength. The tensile strength is nothing but load bearing capacity, right? It is highly resistant to friction because of its high tensile strength. Next, This terline is highly stable at high temperatures. Stable at high temperatures. Next, high temperature. It is stable at high temperature. Next, it is highly resistant to acids. Highly resistant to acids and bases. Highly resistant to acids and bases due to its insolubility in organic solvents. Mainly due to its insolubility. Right? It is highly resistant to acids and bases due to its insolubility. Insolubility in organic solvents. Right? In organic solvents. Organic solvents. Next, it is mainly used for making plastic bottles. It is used for making plastic bottles, and it is also used for making magnetic recording tape. What's it? Used for making magnetic recording tape, and also jars. Right? So this is about terline. Right? Highly resistant to friction because of its high tensile strength, load bearing capacity, stable at high temperature. It is resistant to acids and bases mainly due to its insolubility in organic solvent, used as insulating material and also used as insulating material, right? Use it for making plastic bottles and use it for making magnetic tapes and jars. So this is about nylon 6,6. So formed by condensing terephthalic acid with ethylene glycol, right? So this is about terline, right? Next topic, that is rubber elastomer. So generally, rubbers are high polymers capable of returning into its original shape, length and size after being stretched or deformed. So rubber which is obtained in nature is known as natural rubber, and the polymers which are prepared in laboratories, right? Prepared in laboratories are called synthetic rubbers, are nothing but which are similar to natural rubbers, right? Are called synthetic rubbers, which are prepared in laboratories are called synthetic rubbers. So this destructive distillation of this natural rubber, it gives isoprene as the main product. So isoprene, what is isoprene? So this destructive distillation of this natural rubber gives isoprene as the main product. Isoprene is nothing but 2-methyl 1,3 butadiene. 2-methyl 1,3 butadiene. In chemistry, but means 4 carbons, right? Here I am writing 2-methyl 1,3 butadiene. But means 4 carbons, done. Diene, 1,3 diene. First carbon, second carbon, third carbon, fourth carbon, 1,3, right? And second question, 2-methyl methyl group, 2-methyl 1,3 butadiene is nothing but isoprene, right? 2-methyl 1,3 butadiene. This is isoprene. But X-ray diffraction studies have shown that in natural rubber, these isoprene units are mainly arranged in cis form, right? That is cis form. I am writing here cis form. That is this one shifts here and this here. So a double bond between carbon and carbon, right? H, 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 CH2, CH2 and CH3, same side, right? So cis, this is nothing but cis isoprene. Cis means same side, right? Same side. So this is cis form. And transform, what should I write here? Transform, here I am writing transform opposite, right? So what should I write here? C double bond C, CH2, CH2 and H, CH3. This is transform. Cis and trans. Cis and trans. These two are nothing but these are called as geometrical isomers. Cis and trans. Right? So rubber is a elastomer. Right? Rubbers are generally it is capable of returning into its original shape, length, and size after being stretched or deformed. So this is about rubber. Next, vulcanization. Vulcanization of rubber. Yes. Now coming to vulcanization. What is vulcanization? So vulcanization is nothing but it is the process of heating raw rubber with sulfur at 100 to 140 degrees centigrade is known as vulcanization. Right? So before that, drawbacks of raw rubber. First we'll discuss about drawbacks. What are the drawbacks of raw rubber? Why rubber needs vulcanization? Right? So first, drawbacks of raw rubber. Right. So generally this raw rubber, it is plastic in nature, soft at high temperatures and brittle at low temperatures. So this raw rubber it is mainly used in the temperature range of 10 to 60 degrees only. 10 to 60 degrees only. And this raw rubber, it possesses low tensile strength, right? That is 200 kilogram per centimeter square. And this raw rubber, it absorbs more amount of water. And it is non-resistant to non-polar solvents. Non-polar solvents like gasoline, benzene, gasoline, carbon tetrachloride, etc., etc. But it is highly attacked by oxidizing agents, right? Raw rubber is highly attacked by oxidizing agents such as chromic acid, nitric acid, sulfuric acid, etc., etc. And this raw rubber, it is swells in organic solvents, right? So these are the general drawbacks that I'll write here. Drawbacks of raw rubber. This raw rubber, it is plastic in nature. And it is soft at high temperatures and brittle at low temperatures. So it can be used in the temperature range of 10 to 60 degrees. 10 to 60 degrees only. Done. Next, second one. It possesses low tensile strength. That is 200 kilogram per centimeter square. Possess low tensile strength. Next, it absorbs more amount of water. Next, this raw rubber, it is non-resistant to non-polar solvents. Non-resistant to non-polar solvents. Non-polar solvents like benzene, gasoline, carbon tetrachloride, etc., etc. But it is highly attacked by oxidizing agents. Such as nitric acid, chromic acid, sulfuric acid, nitric acid, chromic acid, etc. etc. And this raw rubber, it swells in organic solvents, So these are the general drawbacks of raw rubber. So to improve the properties of rubber, it is chemically compounded with chemicals like sulfur, hydrogen sulfide, and benzoyl chloride. Sulfur, hydrogen sulfide, and one more, that is benzoyl chloride. But the most important addition is addition of sulfur, right? Addition of sulfur. So the process of heating raw rubber with sulfur at 100 to 140 degrees centigrade is known as vulcanization. And the added sulfur, it chemically combines at the double bonds of two rubber springs. Right? The added sulfur, it chemically combines at the double bonds of two rubber springs. And the extent stiffness of this vulcanized rubber, it purely depends on the amount of sulfur added, right? So it chemically combines at the double bonds of two rubber springs, right? So the process of heating raw rubber with sulfur, at 100 to 140 degrees centigrade is known as vulcanization, right? So here I am writing, right, a raw rubber, that is isoprene 2-methyl 1,3 butadiene, two rubber spring. What I said, the added sulfur, it chemically combines at the double bonds of two rubber springs, that I am writing here, right? So CH2 CH3 double bond CH, CH2 CH3 double bond CH and CH2 and so on. One rubber spring, and the other rubber spring is, here I am writing CH2, right? CH2 also, and so on, right? CH2 and so on. And the other rubber spring is CH2 CH3 double bond CH, CH2 CH3 double bond CH and CH2 and so on, right? Two rubber springs, raw rubber with sulfur heating, right, at 100 to 140 degrees centigrade is known as vulcanization, right? So here I am writing vulcanized rubber. Just a minute. Vulcanized rubber. Yes. So vulcanized rubber. So what I said, it combines at the double bonds of two rubber springs. That is, here I am writing CH2 CH3, right? CH3. So instead of double bond, what should I write here? Single bond CH2 CH3. Instead of double bond, what should I write here? Single bond CH2 and so on. Next, another rubber spring, that is CH2 CH3 CH2 CH3. Instead of double bond, single bond CH2 and so on. Right. Next, what should I write here? Sulfur linkage, right? So the added sulfur combines at the double bonds of two rubber springs. Two rubber springs. This is nothing but vulcanized rubber. Nothing but vulcanized rubber. Okay. So, process of heating raw rubber with sulfur at 100 to 140 degrees centigrade is known as vulcanization. This one is nothing but vulcanized rubber. Now, what are the advantages of vulcanized rubber? And this vulcanized rubber, it possesses high tensile strength, that is high tensile strength 2000 kilogram per centimeter square. Good electrical insulator. It absorbs less amount of water. It is highly resistant to non-polar solvents. These are the advantages of vulcanized rubber. Right? So once again, vulcanization of rubber. First, drawbacks of raw rubber. Why rubber needs vulcanization? What are the drawbacks? Right? So drawbacks of raw rubber. Raw rubber is plastic in nature, soft at high temperatures, brittle at low temperatures, can be used in the temperature range of 10 to 60, possesses low tensile strength, absorbs more amount of water. Next, non-resistant to non-polar solvents, attacked by oxidizing agent, smells in organic solvents. So to improve the properties of rubber, it is chemically compounded with chemicals like sulfur, hydrogen sulfide and benzyl chloride. But the most important addition is addition of sulfur. So process of heating raw rubber with sulfur at 100 to 140 degrees centigrade is nothing but vulcanization. And the added sulfur, it chemically combines at the double bonds of two rubber springs. Vulcanized rubber. Next, advantages of vulcanized rubber. So this vulcanized rubber possesses high tensile strength, that is 2000 kilogram per centimeter square, absorbs less amount of water, good electrical insulator, highly resistant to non-polar solvents. So these are the advantages. Clear? So process of heating raw rubber with sulfur at 100 to 140 is known as vulcanization. So this is about vulcanization. Okay, and we left with preparation properties and the uses of synthetic rubbers that we'll discuss later. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.